All comparison operators return either true or false after evaluating their operands. Let's go over them now, starting with the equality and strict equality operators. This double equals is called the equality operator. The triple equals is the strict equality operator. The double equals is more relaxed about the data type of what you're comparing. It checks for what's called loose equality. The data types of its operands are not required to match. The triple equals, however, checks for strict equality. The data types of its operands must match. Please open your developer console in your browser and type with me. If you type 2 double equals 2, that will get you true. If you type 2 triple equals 2, that will also get you true. So far so good. Now type 2 in quotes, double equals 2. Then type 2 in quotes, triple equals 2. Why is this one true and this one false? Well, the left operand here is a string, and the right operand is a number. And the strict equality operator cares about the types that you're comparing. Let's try another one. With loose equality, 0 double equals false is true, even though 0 is a number data type and false is a Boolean data type. What about 0 triple equals false? Pause and try it for yourself in your console. Keep in mind that it's considered best practice to always use the triple equals, the strict equality operator, unless there's a good reason to otherwise. Next, let's review the inequality operator. This bang equals is the inequality operator. When you have two equals, that's the strict inequality operator. This is the loose not equals, and this is the strict not equals. If you were to say 0 loose not equals false, what do you think you would get? Well, if 0 loose equals false is true, then 0 loose not equals false is false. So what do you think you would get if you tried 0 strict not equals false? Pause and try it for yourself. The greater than, less than, and greater than or equal to, or less than or equal to operators do not have strict or loose versions. It's easy to understand these operators in relationship to numbers. 10 is greater than 5 is true. 7 is less than or equal to 6 is false. 0 is bigger than or equal to 0 is true. Now you can also use these operators to compare strings. When you compare strings, it's the letters that are compared, starting with the first letter, then moving left to right. And the comparison is roughly alphabetical, with letters toward the end of the alphabet being higher than letters to the right. So albatross is less than zebra is true. Let's talk about logical operators. Here we have and, or, and logical not. These are such basic yet powerful concepts. Like the comparison operators, these also return true or false. Let's go over the logical not operator first, since we just saw that used with not equals. The exclamation point or bang operator is known as the logical not. It returns the opposite of the Boolean value of its operand. It only takes one operand. Go ahead and open your developer console and try entering bang true and bang false to demonstrate this. Test out what happens if you use it with a number and a string. For example, bang -3 or bang bagel. Why is that? Why would the opposite of bagel be false? The secret is this: all values can be converted to Boolean values. There are two ways that values get converted to a different data type. There are ways to do it explicitly, and that's called type conversion, also known as type casting. You could, for example, explicitly convert a number to a string using the global function string. Often in JavaScript, data types get automatically, implicitly converted to a different type. This is called type coercion. And you have seen this before, we just haven't talked about it yet. When we talked about the loose equality operator, the double equals, what's actually happening when you try to compare a number and a string is that the JavaScript engine will secretly convert a string to a number before doing the operation. Also, remember how the string concatenation operator will return a string when you try to add a string plus a number? That there is type coercion again, except there the number got turned into a string. And that's what's happening here with logical operators. Logical operators only work with Boolean values, true or false. So if you give them operands that do not have the Boolean data type, then they will coerce the types of those operands to Boolean true or false. And if that value is Boolean true, then we say that the operand is truthy. If that value is Boolean false, then we say that the operand is falsy. So for example, bagel is not Boolean true because it's not a Boolean variable, but it is truthy because if it is converted to Boolean, it would be true. As for how values are converted to Boolean, the rules are actually quite simple and easy to remember. Any value that is 0, an empty string, undefined, null, or nan, not a number, is converted to false. All other values are converted to true. That's it. That's the rules. So that answers why -3 and bagel are converted to true or truthy. A number can be positive or negative, and a string can be anything. As long as the number is not 0 and the string's not an empty string, then it's truthy. Now we can circle back to the logical not operator and understand how it works. When we did bang -3, it first converted -3 to Boolean true. Then it returned the opposite, Boolean false. As a bonus, a shortcut way to get the Boolean value of any variable is to use double bangs. Bang bang -3 will return true, for example. It's converting to Boolean, then getting the opposite of the opposite, if that makes sense. The longer way to convert a value to Boolean would be to use the global Boolean function. The logical AND operator takes two operands and checks if both are truthy. It returns a truthy value if both are truthy, and a falsy value if either is falsy. Let's think about that. If someone says to you, "Do you want chicken and dumplings?" and you can only answer yes or no. Let's say that you want dumplings, but you don't want chicken. Then you have to say no, even though it's true that you want dumplings. When you use a logical AND, that means both operands have to be truthy. Let's try it out. In your console, type true and true. The result is true. Type false and false. The result is false. Type true and false. You'll see that the result is false. Type false and true. The result is false again. It doesn't matter which side the false value is on. If either side is false, then the whole expression is false. Now, there's a little gotcha here, and this will be important for people who may be coming from other programming languages. It's that in JavaScript, unlike some other programming languages, the return value of logical AND is not always Boolean true or false. It was in the examples that we just saw because we were evaluating Boolean values. However, if you evaluate non-Boolean values, it will convert them to Boolean for the evaluation, but what it returns is the original value and not the converted one. So if you're comparing two values that are truthy, then it will return the last one. But if you are comparing two values and one or both are falsy, then it will return the first falsy value. Try out some comparisons of your own in your developer console. One more thing I want to mention that you can try out for yourself. You can chain ANDs together. What happens if you type true and null and 5? The OR operator, on the other hand, will check if either of its operands' Boolean values are truthy. Type this into your console, true or false. This returns true. Try false or true. Once again, we see that the order doesn't matter. It returns true because one of the operands was true. The only time that the OR operator will return false is if all its operands are falsy. When you use the logical OR with operands that are not Booleans, you will get back the first truthy value. If there are no truthy values, then you get back the last falsy value. Again, you can chain logical ORs together. And you can chain logical ORs with ANDs as well. Back to our chicken and dumplings example, if someone asks you, do you want chicken or dumplings? And again, you want dumplings but not chicken? This time, you can say yes even though you don't want chicken. In the next lesson, you will review the if-else conditional statements. The concepts that you've learned in this lesson will help you in that lesson.